Hi, everybody. I am Dr. Anita Emmersdorfer-Augustin, and I am a molecular biotechnologist at ACIP, the Austrian Center of Industrial Biotechnology. My team and I are involved in the Horizon 2020 project Bioplastics Europe, where we develop bio-based and biodegradable plastic materials and investigate their enzymatic degradability. In this module, 2.1, I will focus on the multitude of fossil-based, bio-based, and biodegradable plastics. This module comprises 3 different units. In Unit 2.1.1, I am going to talk about definitions. What does fossil-based, bio-based, and biodegradable mean? In this regard, I will also give a technical perspective. Let's get started. So what does fossil-based, bio-based, and biodegradable mean? A technical perspective. For fossil-based plastics, the primary source is based on mineral oil, natural gas, or coal. For bio-based plastics, the primary source is based on renewable biological or organic feedstock. And for biodegradable, the fossil-based or bio-based material can be degraded by microorganisms in the environment or in biotechnological processes to smaller molecules. Conventional plastic is a monomeric material that is based on petrochemical intermediates stemming from mineral oil. Examples would be PE, PET, or PP. Of course, these are just abbreviations. The long names are given on the right side of the slide. As you can see from this list, the majority of commonly used conventional plastics is still fossil-based. And as we all know, these resources are limited. Furthermore, most conventional plastics are not biodegradable, independently whether they are produced bio-based or fossil-based. If we could make a wish, plastics of the future should be derived from bio-based resources and should be biodegradable. The good news is that there are alternatives. Bio-based plastic materials, at least partly, derived from renewable feedstocks, as for example, lignocellulosic feedstocks, organic waste, or microorganisms, and have properties that are identical to fossil-based plastics. These bio-based PE, PET, or PVCs are technically equivalent to their fossil counterparts. But, big question coming up, are all of these also biodegradable? Materials are biodegradable if they can be converted to natural substances by enzymes produced by microorganisms. And products thereof would be, for example, water, carbon dioxide, and compost. The process of biodegradation strongly depends on the environmental conditions, such as the presence and quality of water, soil, and oxygen. Here we find plastics that are bio-based, and here we find plastics that are biodegradable. A very common misunderstanding is that bio-based plastics are always also biodegradable, but this is not the case. Biodegradation and biodegradability is not a matter of the resource basis, but of the chemical structure of the plastic material. Materials such as PBS, PLA, or PHA, or starch blends are biodegradable and bio-based plastics. This picture here gives an overview about all these definitions again. The most important take-home message for you are: bio-based does not necessarily mean biodegradable, and a plastic material is defined as bioplastic if it is either bio-based or biodegradable, or both.